function, because I said we are going to revisit the meaning of the word function. What is a function? A function in the mathematical context is a set of input with each input relating to the exact output. Now, in simpler terms, a function is just an equation. Think of any equation. Think of a linear equation. Think of a quadratic equation. Think of a cubic equation. Any polynomial equation. Any type of an equation is said to be a function. So now you have understood what a function is. Now let us look at this example of ours here. We have decided to use this example to illustrate what a function is. If a function is equal to y, which is equal to 3x squared plus 4x minus 2, that is a function, then we will say that it is related to some set of inputs. Now the input is x. Any x value that shall be substituted is what we call an input. Look at the definition. That is the input, or rather we can call it independent variable. And this y, whatever that will come out from after substituting the values, the output, this is what we call the output. So we have already known what an input is and what an output is. I'm not going to detail about function because we're not talking about functions. Maybe I'll reserve that later. Now, what is a gradient function? A gradient function is also known as a derivative. Can be called a derivative. It is a change in the function with respect to the change in the independent variable. So when there is a change in this particular function with respect to the independent variable, then we say that is a gradient function. Now let us look at it into detail, and so that we are able to derive a gradient function, or rather a derivative. Now, when you look at that diagram that has been shown, it will be very simple for us to get the gradient of this particular line. But look at this curve. Look at this curve. The gradient of this curve is not uniform. At this point, let's say, the gradient at this point is different from the gradient at this point. The gradient at this point is different from the gradient at this point. Now we want to calculate the rate of change of this curve. Let's say the equation of the curve is given by y is equal to x power n. Now, we are going to talk about differentiation of polynomial. This is a polynomial function. Y is equal to x power n. So if the function y is equal to x power n, the gradient function is just the same as saying dy over dx. So dy dx. Now dy is the change in y, and the dx is the change in x. So dy over dx is equal to n multiplied by x power n minus 1. What we are supposed to do here is just to drop this n here, and then you subtract the power we subtract the power by 1. So we say n minus 1, and then you drop the n there. So n multiplies x. Now let us look at our function. This is the same function that I used when I was defining what a function is, and I was using it as an example. Now, how can we get the gradient function of this particular function, or rather, how can we differentiate this particular function here? The function is y is equal to 3x squared plus 4x minus 2. So that dy dx is equal to, so you drop this 2 here, so 2 has been dropped there, 2 times 3x. This is, the powers should be subtracted by 1, so 2 minus 1. And you see that is plus 4x. We drop 1 there, so that, but 1 times 4 is just 4. So x minus 1. Okay, you see that? And the final answer is dy dx is equal to 6x plus 4. Why 6x plus 4? 3 times 2 is 6. 1 minus 1 is 0. You need to note any number raised to 0 is equal to 1. So 4 times 1 is 4. Consider this is the final answer. But something to note, the derivative of a constant is equal to 0. And that's why this has not been included in the final answer. We have not included 2. 2 is a constant. Why are we saying it's a constant? Because it is not, does not have an x. Now, we have already seen how to do a differentiation.